This is Richard Rogers, and this is
Arnold.
we're doing a problem in Chapter 8, which is Chapter 8, page 270, problem number 7. You can see it there. The problem says a population consists of the following 5 values: 12, 12, 14, 15, and 20. Part A is list all the samples of size 3 and compute the mean of each sample.
The first thing we should know is to find how many samples we have in the distribution by using the combination formula. And the combination formula is big N combination little n. The big N is for the item, the number of items in the population, and the little n is the number of items in the sample. So let's say n is 5 and little n is 3. So the combination formula is going to be 5 combination 3, which is 10 samples. So we found 10 samples in the distribution. The next thing is to find all the possible sample in the distribution.
Alright. And our samples we found are combinations 12, 12, and 14, which equals, if you add that up, is 38. Our combinations were 12 possible samples were 12, 12, and 14, 12, 12, 15, 12, 12, 20, 12, 14, 15, 12, 14, 20, 12, 15, 20, 12, 14, 15, 12, 14, 20, 12, 15, 20, and 14, 15, 20.
The next thing is to sum the sample and divide by the number of sample, which is 10 in this case.
So by summing each sample and then dividing by 3, our total is 14.601.
The book also says to find the population mean, and we need to add all the 5 values. So 12 plus 12 plus 14 plus 15 plus 20 equals 73, and divide by 5 because we have only 5 values, and which is 14.6, which is close to the sample mean.
Our question is, Mattel Corporation produces a remote-controlled car that requires 3 AA batteries. The mean life of these batteries in this product is 35 hours. The distribution of the battery lives closely follows the normal probability distribution with a standard deviation of 5.5 hours. As a part of its testing program, Sony tests samples of 25 batteries.
The shape of distribution of the sample mean. Givens are, we have been given the 35 hours, which is the battery, the product, the population. Our sigma is 5.5 and the sample mean is 25. To find that, since It's said in the problem that this follows a normal probability distribution, so this is a normal probability distribution. And the part 1, to find the shape of the sample mean, we have to go by the error. We have to find the error, standard error of margin, which is, we have to know first what is standard error of margin. It measures the variation in the sampling distribution of sample mean. The formula is sigma x bar equals sigma divided by n, which is 5.5 divided by square root of 25 equals 1.1.
Now they're asking for the proportion of the samples will have a mean useful life of more than 36 hours. So we use the formula for the z value, which is the x minus mean divided by the standard error of the distribution sample mean. As we all know, the standard error is sigma divided by the square root of n, and that gives us 36 minus 35, all divided by 1.1. It gives us the answer of 0.91, which we will now look up the value, its c value on the table. We come up with 0.3186, and we now divide that by 0.5. Subtract it by 0.5, and we get 0.1814.
You say 1 is at 0.5.
So we know that the whole area is 1. Half of that is 0.5. And that is the area that we are looking for. This is the mean, and this is 0.91. So this is the area that we are concerned about. Okay. Question for letter D. You want to read the question? So on letter D, it asks us for the percentage of the sample means that will be greater than, the proportion of the sample that will have a mean useful life greater than 34.5 hours.
Number D is the G value is x minus mu divided by the proportion of the sample means as this one, right? The G value is x minus mu divided by standard error of the distribution sample mean. The equals is 34.5 minus 35 divided by 1.1 equals G value is 0.45. This answer for 0.1736. This G value. The question means 34.5. The greater than is 0.5 plus 0.1736 equal answer is 6.6736.